Hi guys, welcome back. In my previous video, we introduced the power rule for integrals and I have already written it out here as well. And now we're going to start using the power rule and other rules. I don't have enough space here to write all the rules, but I expect you to use a formula sheet or have your textbook in front of you. And we're going to start actually solving some integrals. We'll start with easier ones and then we're going to look at more challenging ones as well. As you start learning the simpler ones, then you will be more confident and then you will be able to look at the more, you will be able to deal with more challenging ones as well. So guys, let us start with this one. Again, it's not such a complicated function. So the first thing that we would like to do is that we want to first try to simplify this piece, and simplifying in this case obviously would mean like we want to distribute, right? So let us go ahead and start distributing. Guys, this times this, so we know that when the bases are the same, what do we do with the exponents? We add the exponents. So we can simply just rewrite this as 1/4 plus 5/4 because we have to add the exponents, and then minus the next term. There's nothing much we have to do except for just writing it out, 4x to the power 1/4. Okay, and then this whole thing is with respect to dx. Okay, guys, we have these two terms, so we can basically break it into two pieces. We're allowed to do that, and so we can rewrite this as integral x to the power, and meanwhile we can just combine these. We already have common denominator, so it's going to be just 6/4, and then dx, well, dx will be with both the terms because we're just breaking them into two pieces. Then the second piece would be the integral 4x to the power 1/4, and then there's a dx as well. Okay, this can be simplified further. It is x to the power, well, 6/4 can be simplified as 3/2, so we should first do that before we move on. And then minus. Guys, here keep in mind, whenever we have a constant multiplied by this polynomial function of the form x to the power n, what do we do with the constants? We usually take them outside the integral. Okay, so I'm going to take that constant outside the integral, then integral x to the 1/4 dx. That is the first few steps. Okay, first we distributed it, combined, well, we added the exponents, then we had to simplify them. Here we have a constant multiplied to this function, so what we do is we take that constant. Every time we have a constant multiplied, we just take it outside. Okay, that's just a basic property. And then from here, let us see if we can now use the power rule. Guys, from here we can use the power rule on this guy and this guy because they both are in the form x to the power n. Okay, so using the power rule on both this one, what do we get? Let's see, we need more space. So I will get, for this I'm going to get x to the power 3/2, and what do I have to do to the exponent? Guys, my power rule tells me I just have to add 1. So it's not too complicated, you just have to follow the rule. And then the same thing, whatever is on the exponent is going to be in the denominator. Again, that's exactly what the power rule says. And then there's a minus 4. This 4 will stay, no need to do anything with that 4 yet. And then there's an x to the power 1/4 plus 1, and then 1/4 plus 1. And don't forget there's plus c as well. Just have to keep on writing that plus c. Now let us simplify things. So from here, this becomes x to the power 3/2 plus 1 is going to end up with 5/2. Alright, you have to just create a common denominator and then just to combine the numerators. And then there's going to be 5/2 downstairs as well. Here there's going to be -4, x to the power 1/4 plus 1 is going to be 5/4. I'm sure you can simplify those, like add those 1/4 and 1 on your own as well. And this is 5/4 as well. Guys, I'm skipping that step because I expect you to be able to do that. Okay. From here, again, there's few more, probably one more step. Guys, this whole division can be converted to multiplication. So if I convert it into multiplication, then this thing flips. So instead of dividing by 5/2, it will be multiplied by 2/5, x to the power 5/2. Okay. And then same thing happens here. This quantity is divided by a ratio 5/4, but if I change this division into a multiplication, it would be basically multiplied by 4/5. So it will be 4/5 times 4 x to the 5/4 plus c. There's already that 4, that's this 4, and then this flips 4/5. Okay, so we're almost done. This term is already in the simplified form, except for there's one thing that we can do here, which is 4 times 4, and we have to do that. We have to simplify that. So 4 times 4 is 16. You should actually write it in the next step. I don't have room here, that's why I'm just doing it right there. 16 over 5, and then there is this, and then plus c. That's it. Guys, this is the integral. This is the integral of this function. This is the integral for this function, and we just simplified things, use the power rule, and finally we have this. And we know the idea of this antiderivatives. If the integral of this function is this, then if we try to take the derivative of this function, we should get that function back. Okay, so that is the first example. We're starting with a simpler one. Guys, I'm going to show you a lot more examples, so start practicing these basic ones, and then we'll learn some different ones and more challenging ones as well.